Hi, welcome to the chain rule. The chain rule is great when you've got one function put inside of another one. The idea is you want to do the derivative of the outside and then multiply that by the derivative of the inside. But it's tricky to figure out what's on the inside and what's on the outside. So I sneezed and the cat leaves. If you get this exponent and this 6x minus 5, you're kind of like, well, I got to do something with that x to that fourth exponent, and I've got to do something with that 6x minus 5. Well, that's sort of your inside, your 6x minus 5, and that power of 4 is your outside. Same thing, we've got like that fraction happening in the second example, and then we've also got the x plus 1 Mills back. So let's try one out. They actually told us what the inside was on this one. It was square root of 3x. We want to figure out what that derivative of the inside is because we're going to need it a little bit later. We don't know what it is right now, but let's just figure it out. I don't want to e. I would like to use u prime. The derivative of the square root of 3x is just going to be the square root of 3. So to do this derivative, we would just kind of imagine we were trying to figure out y cosine of just whatever, or RU. The derivative of cosine is negative sine. So that's our y prime. And then we just say, okay, well, then we need to multiply that by whatever u prime is. Well, u prime, we just found out, is the square root of 3. And u, we knew from the beginning, is the square root of 3x. So this derivative is just negative sine square root of 3x times the square root of 3. If you wanted to, you could write it a little bit nicer. That square root of 3 does not go into the sign. It's just going to be in front. Square root of 3x. And that's done. We did the chain rule. We took the derivative of the outside, the derivative of cosine, then we did the derivative of the inside. Now, this one, they did not tell us what the inside part of the thing was. Now, it's a little bit sneaky for this one because we got to remember that this is a sine of 3x minus 2, and then all that being squared. So our inside part is actually that sine of 3x minus 2. That is our inside part. But in order to figure out, we got to then find u prime, right? So we find the derivative of this. Well, that the derivative of sine is cosine. Oh, but wait, there's still an inside part for that. So we have to do the chain rule yet again. We can chain the chain rule. So I'm going to call it something else. I'll do w is sort of our inside part. So that's 3x minus 2. So w prime is going to be just 3. So in order to figure out u prime, we need to multiply this by 3. So I'll just sneak it in front right there. So u prime will be 3 cosine of 3x minus 2. And then when we do our proper y prime over here, no, this is just y. So y prime is going to be 2, doing the derivative of that squared, sine of 3x minus 2, multiplied by all of this stuff. So times 3 cosine of 3x minus 2. So y prime, if I wrote it all out in a big long line, we got 2 times 3, that's 6. Sine of 3x minus 2. And cosine of 3x minus 2. All done, all done. Now, you might remember from your trig identity days, and I hope you do, that we had a cool double angle identity. The sine of 2 theta was equal to the 2 sine theta cosine theta. So depending upon what this problem is looking for, it may have like a multiple choice and it had a different option. They may, in a multiple choice question, give like a goofy thing like this. and break that 2 and 3 back up, keep this 3, and make this sine 3x, sine of 3x minus 2 and cosine of 3x minus 2, and that 2 into a sine of 2 times that 3x minus 2. There are going to be times where we're going to need to do this identity stuff, so let's just practice a little bit right now. We get 3 sine of 6x minus 4, which is kind of neat because it's a little bit neater. Now, in this one, they were kind enough to give us the derivatives of those parts, but they still are basically asking for the chain rule. E is particularly clear that it's the chain rule. It almost looks identical to what we have on our cool calculus card, or what I showed at the beginning of this video. So to figure out the derivative of that at 2, that would be the derivative of our outside. So f prime, we still keep that g of x, multiplied by the derivative of our inside, which would be g prime of x. But this was asking us to find those values at 2. So we just need to put a 2 in these two spots. So that's f prime of g of 2, and then g prime of 2. Okay, well, they gave us a lot of these values up in that table. So g of 2 is going to be just 2. So that is a 2. Then g prime of 2, that's that negative 4. It's really hard to do this with a tail in your face. Yeah, well, you're the one that's not being helpful. So then we got to do f of 2. Yeah, f of 2. Do you know what f of 2 is? It's 8. So 8 times our negative 4 is going to be what? Negative 32? Negative 32. I thought this bumped down. You're not helpful. You're not helpful. In the next one, we've got a square root sitting on top of that f of x. So it might help to kind of rewrite it a little bit. No, 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 no. Get out of here. She's getting spicy. So our outside part is that 1/2 exponent. That's the function that's happening on the outside, that square root. So it'd be 1/2 f of, and let's just put the 2 in right away. So there's the derivative of the outside multiplied by then the derivative of the inside, f prime of 2. So f of 2, we know that to be 8 from up here. So that is 8 to the negative 1/2. Multiplied by f prime of 2, which is 1/3. And we still got this 1/2. So this is 1 over 2 square roots of 8 multiplied by 1 over 3. So let's see, we could simplify that square root of 8 into a square root of 2 and a 2. Multiplied by 2, multiplied by 3, we get 12 square roots of 2 over 1. And if we simplified it, it would be square root of 2 over, well, 24. Yeah, 24. And I believe that's our simplified value. So overall, the big thing about the chain rule is you need to do the derivative of the outside and then just multiply that by the derivative of what is inside of that function. Be careful when there's multiple chains stacked on top of each other. These can be mixed with other derivative rules in order to do other cool derivatives. Thanks for watching. Bye-bye.